denominator next to this annoying perfect square. Do you know how to rationalize a way to get me out of here? Today's lesson, we will continue simplifying radicals, but instead, today we will have the division of radicals, also known as fractions. And then we're also going to learn how to rationalize the denominator, which is just a way to get the radical out of the denominator, because your final answer can never have the square root symbol in the bottom of your fraction. It's going to be fun! Now we're going to start simplifying radicals that are within fractions. And then one rule to keep in mind is if you have the square root of a number divided by the square root of another number, what you can do is divide the two numbers first and then take the square root of them. And then with these problems, sometimes you'll start with something like the left side, and you'll want to do a divided by b and then take the square root of it. And then in other cases, maybe we start with a fraction underneath the square root, and it's going to be more beneficial to us to break it apart. And it'll just take you doing a few of them to really understand the idea. But before we move on, one quick thing to consider. This is where some students make mistakes. Let's say we have the square root of 3 divided by 3. I've seen a lot of students try to just cross those 3's out because they know that 3 divided by 3 is 1. But this 3 is underneath the square root, so you cannot just cross those 3's out. The only way you could do that is if you had the square root of 3 divided by the square root of 3. Then it's the square root of 3 over 3, which is 1. But in this original example, that is actually the most simplified example of that radical expression. Okay, the first example, I have the square root of 11 over 49. So let's think about this rule. We want to simplify this. If we did 11 divided by 49 right away, we would just get a decimal, and that wouldn't be helpful at all. And since I noticed that 49 is a perfect square, so I probably just want to take the square root of that. So let's break apart this radical and have the square root of 11 divided by the square root of 49. And then simplify from there. The square root of 11 doesn't have any perfect factors, so that's fully simplified. And then the square root of 49 is 7. And there it is. There's my answer, simplified form. Okay, example number 2 is the square root of 18x to the 4th divided by 25. Let's see, what do I have? I've got 25 is a perfect square, x to the 4th is a perfect square, but that 18 is not, but it can be simplified because it has perfect square factors. I'm going to break this apart. So I'm going to take the square root of the numerator, 18x to the 4th, and then the square root of the denominator, because 25 is a perfect square. So if I want to simplify this on the top, I can break 18 up into 9 times 2 times x to the 4th, and then divided by, what's the square root of 25? It is 5. And now let's simplify the top. We have the square root of 9 is 3, and then the square root of x to the 4th is x squared. So I have 3x squared, square root of 2, all over 5. And now you always want to double check, can you simplify this fraction any further? And that means if you have coefficient numbers, can they be simplified any further as a fraction? In this case, they cannot, so this right here is your final answer. Okay, now we have the square root of 12a to the 3rd divided by the square root of 27a. So right now, there are no perfect squares underneath my radicals, and my radical is broken apart, separate from the numerator and the denominator. So I'm going to bring it together and look at 12a to the third over 27a. And the reason I do that, I want to see what's going to happen if I simplify what's underneath the radical and then worry about taking the square root. So if you divide 12 divided by 27, you just get a decimal. But can you simplify it is the question. Let's see, 12 over 27, you can divide them both by 3. So we have the square root of 4/9. And then a to the third divided by a simplifies to a squared. So now, once I've simplified everything, look what I have. I have 4, a squared, and 9. All of those are perfect squares, so I can just take the square root of all of them. The square root of 4a squared divided by the square root of 9. So this is 2a over 3. And that is my final answer.
Gosh, you're so perfect.
Don't be so irrational. I have to admit, though, we are both pretty radical. Now we're going to learn how to rationalize the denominator. And this is the method that allows us to get any square roots out of the bottom of the fraction. Because to be in most simplified form, you just simply cannot have a radical in the denominator. And one quick thing to keep in mind that is going to help us, if you do the square root of a times itself, the square root of a, it cancels out the square root and leaves you with simply a. So let's look at that with maybe some numbers. The square root of 5 times the square root of 5 would be the square root of 25, and the square root of 25 is 5. So that's why that works. We're going to use this idea in today's lesson. Okay, for our first example, we have 2 divided by the square root of 5. And we want to get radical out of the denominator to fully simplify this. So what we're going to do is we're going to multiply our fraction by another fraction that is equivalent to 1. And whatever is in the denominator, you're going to create a fraction using that radical, square root of 5 divided by the square root of 5. So technically, this fraction just equals 1, because anything divided by itself is 1, so we're not changing anything. We're just helping simplify. So if we're going to multiply 2 times the square root of 5, it is simply 2 square root of 5. And then square root of 5 times the square root of 5 just cancels the square root out and leaves you with 5. And then you always want to check, can your front numbers be simplified any further? In this case they cannot, so this is your final solution. Okay, the next example is the square root of 7 divided by the square root of 8n. And I want to get the radical out of the denominator, so I'm going to rationalize it, which means I'm going to multiply by another fraction and just take whatever's in the denominator, and then we're going to put that in the numerator and in the denominator. And we do that so we can cancel out the radical in the denominator, and really you're just creating a fraction that equals 1, so you're not actually changing anything. So now, if we multiply the top, we have both of these are under square roots. So we can multiply 7 times 8n together. So we have the square root of 56n divided by the square root of 8n times the square root of 8n is just 8n. And now we still have to simplify that square root of 56n. So are there any factors of 56 that are perfect squares? I can break 56 up into 4 times 14. This is all over 8n. And then I can take the square root of 4. And the square root of 4 is 2. So I have 2, and then underneath is the square root of 14n all over 8n. So I'm almost done. One last thing. The numbers out in front, you always want to see if they can simplify. And 2/8 simplifies to 1/4. So my final answer is the square root of 14n over 4n. So all of that, simplifying this radical by rationalizing the denominator to get that as my answer. Okay, here's the final example of the lesson. And there's a lot going on, so you might want to write a little on the small side. Here we have the square root of 5 over 18x. Alright, so remember the rule from before that we can break this up so we have the square root of 5 over the square root of 18x. Well, now we have a radical in the denominator and we have to rationalize the denominator. So I'm going to multiply by the fraction square root of 18x over the square root of 18x. Can multiply across and multiply across here. So in the denominator I have 18x, and on the top I have the square root of 90x, because 5 times 18 is 90. Now I need to simplify 90. So what factors of 90? Let's think 9 and 10, and 9 is a perfect square, so that will work. So the square root of 9 times 10, and then we still have an x, over 18x, and 9 is a perfect square, so the square root of it is 3. So I have 3 square root of 10x all over 18x. So I'm almost done. Look at the numbers out in front. 3 over 18, how does that simplify? That simplifies to 1 over 6. So the square root of 10x all over 6x is my final answer. Well, I rationalized the denominator from before, but I don't know if this is any better. No!